Hey everyone and welcome back to the channel. Today, we're diving into a super fun project that combines a little bit of crafting with a whole lot of physics. Get ready because we're going to build our very own rubber band powered car. This is one of those classic experiments that is not only a blast to build but also teaches us some really cool science along the way. All you lines need are some simple materials you probably already have lying around the house. A piece of sturdy cardboard for the car's body, a couple of plastic straws for bottle caps for wheels, some wooden skewers for axles, and of course the star of our show, a rubber band. Oh, and you'll want some hot glue or strong tape to hold it all together. So grab your supplies and let's get ready to turn these everyday items into a moving machine. First things first, let's build the chassis, which is just a fancy word for the car's frame. Take your piece of cardboard and cut out a rectangle. The size is up to you, but something around 3 inches wide and 6 inches long is a great place to start. This will be the base of our car. Now, take 2 straws and cut them so they're just a little wider than your cardboard chassis. These straws will hold our axles. Let's glue them across the bottom of the cardboard, one near the front and one near the back. Make sure they're parallel to each other. This is a really important step because if your axles aren't straight, your car might not roll in a straight line. Once the glue is dry, we've got a solid foundation for our vehicle. Simple, right? Let's move on to the wheels. Now for the wheels and axles, this is where our bottle caps and skewers come into play. Carefully and with a grown-up's help if you need it, poke a small hole in the center of each of the 4 bottle caps. You want the hole to be just big enough for your wooden skewer to fit through snugly. A tight fit is good because it means the wheel will turn with the axle. Next, take one of your skewers and slide it through one of the straws you glued to the chassis. Then, push a bottle cap onto each end of the skewer. These are your wheels. Repeat this process for the other straw and skewer. Give your wheels a little spin to make sure they turn freely inside the straws. If they're a bit wobbly, you can add a tiny dab of glue on the outside of the cap where the skewer comes through to lock it in place, but be careful not to glue the axle to the straw. Alright, our car has a body and wheels, but it can't go anywhere yet. It's time to add the engine, our rubber band. This is where the magic of potential energy comes in. Flip your car over. We need to create an anchor point for our rubber band on the front axle. An easy way to do this is to just wrap the rubber band around the middle of the front skewer axle and secure it with a small piece of tape or a drop of glue so it doesn't slip. Now, we need a hook at the back of the car to hold the other end of the rubber band. You can make a small notch in the back edge of your cardboard chassis. Or, you could glue a small piece of a paper clip onto the back. The goal is to have something to hook the rubber band onto. Make sure your hook is sturdy because it's going to be holding all that tension. So how does this thing actually work? It's all about energy transformation. When you stretch a rubber band, you're storing energy in it. This is called potential energy, specifically elastic potential energy. The more you stretch it, the more potential energy you store. To power our car, we're going to hook the free end of the rubber band onto the hook at the back of the car. Then we'll start turning the front axle backwards, wrapping the rubber band around it. Can you feel the resistance? That's the tension building up. You're winding up the potential energy. When you let go, that stored potential energy is going to be released. The rubber band will rapidly unwind, forcing the axle to spin. And because the wheels are attached to the axle, they'll spin too, pushing the car forward. The potential energy is converted into kinetic energy, which is the energy of motion. Let's test it out. Place your car on a smooth, flat surface like a tabletop or a hardwood floor. Wind up the front axle by turning it backwards, maybe 10 to 15 times. Make sure the rubber band is neatly wrapping around the axle. Now, hold it steady on the count of 3, let it go. 1 to 3, look at it go. How far did your car travel? Was it fast? Was it slow? This is where the real fun of science begins: experimentation. What do you think would happen if you wound the rubber band more times, or less? Try it and see. Winding it more should store more potential energy, which should make the car go faster and farther. But be careful not to wind it so tight that the rubber band snaps. Now, let's become real engineers and think about how we can improve our design. What variables could we change? One obvious one is the rubber band itself. What if you used a thicker, stronger rubber band, or maybe a longer, thinner one? A stronger rubber band can store more energy, but it might also be harder to wind. What about the wheels? Do you think bigger wheels would make a difference? Bigger wheels cover more ground with each rotation, so they might make your car faster. You could try using lids from a larger jar. Another thing to consider is weight. Is your car too heavy or too light? You can try adding some weight, like a coin or two, to the chassis. Does adding weight help with traction, or does it just slow the car down because it takes more energy to move? Let's try a few modifications together. First, let's try a different rubber band. I'm swapping my standard one for a much thicker one. Winding this one is definitely a bit tougher. Okay, let's see what happens. Wow! That one took off much faster, but it didn't seem to go as far. Maybe the energy was released too quickly. It's all about finding the right balance. Now, let's talk about friction. Friction is a force that opposes motion. We have friction between the axles and the straws, and between the wheels and the ground. Can we reduce it? Making sure your axles are straight and your wheels spin freely is a good way to reduce friction in the car as mechanics. What about the surface? Try running your car on carpet versus a smooth floor. It will definitely perform differently because of the change in friction. This simple toy is a fantastic example of Newton's laws of motion. When the rubber band unwinds, it exerts a force on the axle, causing it to accelerate. That's Newton's second law, force equals mass times acceleration. And as the wheels push against the ground pushes back on the wheels with an equal and opposite force, propelling the car forward. That's Newton's third law in action. Every action has an equal and opposite reaction. It is pretty amazing to see these fundamental principles of physics at play in a car you built yourself from cardboard and bottle caps. It shows that science isn't just something you read about in a textbook. It's all around us in everything we do, so I challenge you to get creative. Don't just build one car, build a whole fleet. Decorate them, give them cool names, have races with your friends or family. See who can build the car that goes the farthest, or the fastest, or the one that can carry the most weight. Can you build a car that can climb a small ramp that would require a lot of torque? You could even try different body shapes to see if aerodynamics makes a difference. Maybe a pointy, arrow-shaped car will go faster than a square one. The possibilities are endless, and every change you make is a new experiment. The most important thing is to have fun with it, be curious, and don't be afraid to try something new. That's what being a scientist or an engineer is all about. I hope you had as much fun building this rubber band car as I did. It is such a rewarding project that shows how a little bit of ingenuity can turn simple household items into something truly awesome. Plus, you got a hands-on lesson in physics, exploring concepts like potential and kinetic energy, tension, and friction. If you built your own car, I would love to see it. Share a picture or video on social media and tag us. Let me know what modifications you made and how they worked out. What was the coolest discovery you made during your experiments? Thanks so much for joining me today. If you enjoyed this project, be sure to hit that like button and subscribe for more fun science and DIY builds. Until next time, stay curious and keep experimenting.